Okay, there is one form of factoring that you have not yet been assessed on, and those are perfect square trinomials. So I'm going to give a little tutorial right here, right now with 2 examples, and then I'll be happy to answer questions if you'd like to message me on Adsby. So let's start off with this example. Let's say I am being asked to factor this quadratic trinomial, okay? First thing I always try to do is common factor. However, that can't be done here. There are no numbers that divide evenly into 36, 84, and 49. So if I can't common factor, then I try to decide what type of trinomial is it. It's a hard trinomial because x squared does have a number in front of it. And so our strategy for factoring hard trinomials is decomposition, which means I would be looking for numbers that add to 84 and multiply to whatever 36 times 49 is, which is 1,764. And immediately, if I was writing an assessment, I would definitely stop and scratch my head because Mrs. Kerr would never make us do a decomposition question with numbers this hideous, okay? So if decomposition seems like it's way too hard, let's check to see if this is a perfect square trinomial. A perfect square trinomial is an expression with 3 terms where the very first term is a perfect square, and lo and behold, it is. The square root of 36x squared is 6x. The very last term is a perfect square, which, oh yeah, the square root of 49 is 7. And when I take those 2 numbers and multiply them together, I get 42x. And then when I double that, I get 84x. Since this worked out, this is a perfect square trinomial, and it is so quick and so easy to factor. Square root of the first term goes at the front of the bracket. Square root of the last term goes at the back of the bracket. Sign in the middle goes in the middle, and it is squared. This is very similar to a shortcut you learned in Unit 3. When we square a binomial, we square the first term, that goes first. Square the last term, that goes last. Multiply the terms together and double it, that goes in the middle. So we've totally come full circle by learning how to factor using a shortcut. Now I want to show you another example that's a bit of a double whammy. So let's say I am given this trinomial and asked to factor. First thing we always do, no matter what, is try to common factor. And in this example, there most definitely is a common factor. It is 2. Each of these terms is divisible by 2. Now, pay attention. I am not only going to factor out a 2, I'm going to factor out a negative 2. If the coefficient of x squared is ever negative, that negative needs to be factored out. So when I divide each of these terms by negative 2, I'm left with 100x squared minus 10x plus 1. Okay, now, can this trinomial inside the brackets be factored? Let's check to see if it is in fact a perfect square trinomial. Square root of 100x squared is 10x. Okay. Square root of positive 1 is 1. Okay. When I multiply those guys together, I do get 10x. But when I double it, I do not get negative 10x. So this is not a perfect square trinomial. And you have to be very careful not to fall for those tricks, okay? Okay, let's look at one more example together. Again, this is a quadratic trinomial. It has 3 terms, and we're going to try to factor it. We always check to see if we can common factor first. And again, in this particular question, we can. Each of these is divisible by 3. And I'm actually going to factor out a -3 because the coefficient of x squared is negative. What do we have left inside the brackets? Well, when I divide this by -3, I get 16x squared. When I divide this by -3, I get plus 8x. And when I divide this by -3, I get plus 1. So now, before I move on, I'll check to see, can I factor inside the brackets? Can I factor again? And the answer is possibly. This is a hard trinomial, but before I dive into decomposition, I'm going to check to see if it is a perfect square trinomial. So the square root of 16x squared is 4x. Good. The square root of 1 is 1. Good. When I multiply those together, I get 4x. And when I double it, I get 8x. Excellent. That means this is a perfect square trinomial. Now, when I go to write out my next step, this guy doesn't just disappear. He should appear in every single step, and I made a point of telling you that on your quiz corrections. Now, in the bracket, I'm going to have 4x, so he goes first, he goes last, he goes in the middle, squared.